Good day everyone, my name is Charmin B. Portarcos and I'm going to tackle about incandescence. What is incandescent lamp? Incandescent lamp or incandescent light globe is an electric light with a wire filament that is heated until it glows. The filament is enclosed in a glass bulb that is either evacuated or filled with inert gas to protect the filament from oxidation. So it is a type of electric light. So it is features a wire filament inside a glass bulb. When an electric current passes through the filament, it heats up to the point of glowing, producing visible light. So the glass bulb is either evacuated or having air removed, or filled with inert gas to prevent the filament from oxidizing or burning out too quickly. Despite their historical popularity, incandescent lamps are less energy efficient compared to newer lighting technologies like LEDs. So here are the incandescent lamp parts. So the first one is outline of glass bulb. Next is low pressure inert gas. Then tungsten filament, the support wires, the contact wires, the stem or glass mount, then cup or sleeve, then insulation or vitrate, and electrical contact. So let's move on to the parts and functions. So the first one is the contact wire. So it is electric conductor carrying the current to the filament. The second one is the inert gas. So it is the gas inserted in the bulb to slow down evaporation of the filament. Next is the base. So it is the metal end of a light bulb inserted into a socket to connect it to the electric circuit, or the bayonet base or gitawag siyang screw base. Then the stem. So it is the button support. Then the button is the end of the stem. So it is the filament supports that are attached to it. Then is the next is the support, so metal wire holding the filament. Then second to the last is the filament. So it is very thin metal wire, usually made of tungsten, emitting light rays when an electric current passes through it. Then the last one is the bulb, so gas sealed in a glass envelope into which the luminous body of a lamp is inserted. So here are the history evolution. So in 1801 to 1809, Sir Humphrey Davy made the platinum filament and carbon arc lamp. So the platinum filament is an electric light filament made of platinum. So it is a precious metal, while platinum has a high melting point. So it is not commonly used for light bulbs due to its cost. Then the carbon arc lamp is a lamp that produces light through an electrical arc between two carbon electrodes. So this older technology was used in early cinema projectors and outdoor lighting. Then next is in 1840, so Warren DeLaro made the vacuum tube enclosure. So it is a glass or metal tube from which the air has been evacuated, so creating a vacuum. So vacuum tubes were essential components in early electronic devices such as radios and computers. Then next is Frederick D. Mullins. So he made the powdered charcoal filament in 1841. So it is a filament made from powdered charcoal used in early incandescent lamps. So this material was not as durable as later filaments like tungsten. Then next is carbonized bamboo filament. So Henrik Goebel is the one who made that in 1854. So it is an incandescent lamp filament made by a carbonizing bamboo. So this was an early attempt to create a more efficient and longer lasting filament material. The next is vacuum tube enclosure. So it was made by Joseph Wilson Swan in 1873. So it is the same as what Warren Delario made. Then next is Woodward and Evans. So they made the gas-filled globe in 1875. So the gas-filled globe is a light bulb with a glass envelope filled with an inert gas. So it is like a carbon or nitrogen. So it improves efficiency and increasing filament life by reducing oxidation. Then next is Thomas Edison. So he made a long-lasting filament in 1880. So it is refers to our filament designed for extended durability, often achieved through the use of more resilient materials like tungsten. Then next is Lewis Latimer. It is Latimer. So better filament production. So mo na gibuhat in 1882. So it indicates advancement in the manufacturing process of light bulb filaments to enhance their performance, efficiency, or longevity. So the last one is it's William David Coolidge. So he made tungsten filament in 1910. So it is a widely used filament material in modern incandescent lamps. Tungsten has a high melting point, making it suitable for producing long-lasting and efficient light bulbs. Efficiency. Approximately 90% of the power consumed by an incandescent light bulb is emitted as heat rather than as visible light. So why is an incandescent light bulb is emitted as heat rather than as visible light? It is because the high temperature of the filament produces infrared radiation, which is felt as heat rather than seen as visible light. So this is inefficiency makes them less energy efficient compared to alternatives like LEDs. The differences between incandescent and compact fluorescent lamp. So the first one is the regular bulbs, also known as an incandescent bulbs, create light by heating a filament inside the bulb. The heat makes the filament white hot, producing the light that you see. A lot of the energy used to create the heat that lights an incandescent bulb is wasted, or less than 10% of the energy consumed by incandescent bulbs is for lighting. Then, the fluorescent bulb, on the other hand, contains a gas or mercury vapor that produces invincible ultraviolet light or UV when the gas is excited by electricity. So the UV light hits the white coating or the phosphor inside the fluorescent bulb, and the coating changes it into light you can see. Because fluorescent bulbs don't use heat to create light, they are more energy efficient than regular incandescent bulbs. So we have another examples of the differences between the incandescent lamp and the compact fluorescent lamp. So in lamp life, the incandescent lamp have 750 to 1000 hours only, while in the fluorescent lamp there is 6000 to 15,000 hours. And in the amount of light produced per watt of electricity, the incandescent lamp have only 8 to 15 lumens, while the CFL or the compact fluorescent lamp have 50 to 75 lumens. And in energy efficiency, so incandescent have 10% used to produce light and 90% for heating, while the fluorescent consume only 1/5 to 1/3 of the power of similar wattage incandescent bulbs. So in below is an approximate equivalent to incandescent bulbs. So in CFL is there is 7 to 10 watts, 15 to 18 watts, 20 watts, 20 to 25 watts, 32 watts, while in incandescent there is 40 watts, 60 watts, 70 watts, 100 watts, and 150 watts. And here are the different kinds of bulbs and its types and uses. So the first one is the decorative chandelier. So light bulbs are not only for chandeliers. So many modern fixtures specify the use of a type B light bulb. So mo ni makita nato no sa kanang mga balay kanang kasagaran mo gamit anino kay mga kanang kwartahan jud no anay sila mga chandelier, so mo na nga bulb ang ilang gigamit. The next is Vesta bulbs, so can be used in almost any light fixtures where you use a regular light bulb. These bulbs add a bit of elegance to outdoor residential fixtures and can add atmosphere to business like restaurants. So makita ra ni nato almost nasa mga kanang kananan sa mga like something hotel, like something ana nga kanang na siya sa mga restaurant ng mga lights. Then next is cold beacon. So light bulbs are a specialty bulb for our radio and television towers rated for long life. The most popular is the 620p S40. So makabantay ta na sa kung unsay makita nato didto sa mga tower nga naa sa radio ug television mga towers. So mao na siya nga bulb ang gigamit mo nang gitawag og cold beacon. So the fourth one is the photo flood. So it is the light bulbs that are specialty light bulbs for use in photography. So these bulbs have very intense white light. So mo day para mohayag ang kanang mga like mag-take og mga pictures. So mo ni nga kanang bulb ang gamiton. Then next is the half mirror and silver bowl. So it is the light bulbs are used in restaurants, homes, and other applications where glare reduction is needed. So the top part of the bulb is chrome on the half mirror bulb and opaque white on the silver bowl bulbs. So these bulbs reflect light used in an inverted position commonly or used above restaurant tables, bathroom vanities, and other decorative applications where function and fashion are important. So, common naman ni siya nga gamiton nato sa tuong mga panimalay no nga suga. Then, kani pong rough service. So, light bulbs are often used in garage door openers, machines, and applications where the bulb has to tolerate vibrations. So next is the PS25 and PS35 light bulbs so these are very large incandescent bulbs with relatively high wattage ranging from 300 to 500 watts. So these are often used in churches and buildings with older high wattage fixtures. So kani ay nga bulbs is kanana din siya makita sa mga churches and buildings. So, next is the full spectrum and neodymium light bulb. So, reveal the true colors of objects in the lighted area. So, these bulbs simulate daylight and have whiter than regular light bulbs. So, grabe jud ay kay ni kahayag no. So, next is the high and low voltage specialty bulbs. So, this category contains 12 volt and 220 volt light bulbs that look like a regular light bulbs. So the 12 volt versions are often used for recreational vehicles. So mo ni siya gamiton sa mga kanang mga kanang vehicles no. Then globe shape. So light bulbs are often used for bathroom vanities or in pendant fixtures. So we stock the most popular sizes and wattage in both clear and white ranging from 1 to 8 or 1/8 to 5 inches in diameter. So the second to the last is the reflector flood. So it is the light bulbs that is available in the wide range of sizes and wattage and are usually used in recessed fixtures and track lighting. So the last one is the colored light bulbs. Add to atmosphere to business and are great for parties and holidays. So we have a large selection of bulb types and colors including red, blue, green, amber, yellow, and also pink. So that would be all for the incandescent topic, and let's now move on to the fluorescence topic. So here are the contents of the fluorescence topic. So the first one is the history, next is the introduction, then types of fluorescence, and the last one is the quenching of fluorescence. So the history of the fluorescence comes from the mineral fluorspar or calcium fluoride. So when Sir George G. Stokes observed in 1852 that fluorspar would give off visible light or fluorescence when exposed to electromagnetic radiation in the ultraviolet wavelength. Luminescence is the emission of light by a substance. So it occurs when an electron returns to the electronic ground state from An excited state loses its excess energy as a photon. So it is of three types. So the first one is the fluorescence spectroscopy. The second one is phosphorescence spectroscopy. And the third one is the chemiluminescence spectroscopy. Principle of fluorescence. So the electronic states of most organic molecules can be divided into singlet states and triplet states. So magsugod ta sa single ground state. So all electrons in the molecule are spin paired. So nakita nato na diya sa ubos no kanang usa ra ka line tapos nagpatong na sila sa duha ka arrow. Then ibangga ang usa ka arrow sa line din ang usa is pa-up siya. So, muna siyang single ground state. Tapos, ang single excited state is unpaired electrons of opposite spin present. So, di sila pares. So, muna na sa center. Tapos, the triplet state is unpaired electrons of same spin present. So, parehas sila og kanang kuan. Parehas sila pa upward, no? Then, nagpatong sa linya muna sila ang pero unpaired gyapon sila nga electrons but same silang spin present. So here is the Perrin-Jablonski diagram. So this is a graphical representation of electronic transitions in molecular systems. In this diagram, absorption, fluorescence, and phosphorescence processes are depicted in the context of energy levels. In absorption, at the bottom of the diagram, there is the ground state S0, representing the molecule in its lowest energy state. The molecule absorbs energy typically in the form of light and undergoes an electronic transition to a higher energy state, the S1, S2, and etc. This upward arrow represents absorption. In the fluorescence, after absorption, the molecule may return to the ground state by emitting light of a longer wavelength than the absorbed light. The downward arrow from the excited state, the S1 and S2, to the ground state, S0, represents fluorescence. The emitted light is usually in the visible range. Then, the phosphorescence. So, it is involved in a longer-lived excited state compared to fluorescence. So, the transition from the triplet excited state, the T1, T2, etc., to the ground state S0 is depicted by a phosphorescence arrow. So, phosphorescence emission occurs due to a spin-forbidden transition, leading to a slower return to the ground state and emission of light with a longer wavelength. So, in summary, absorption involves moving to higher energy states. Fluorescence involves returning to the ground state with the emission of light, and phosphorescence involves a longer-lived excited state before returning to the ground state. The Perrin-Jablonski diagram visually represents these processes by showing the energy levels of electronic states in the molecule. So here are the principle of fluorescence. So energy of emitted radiation is less than that of absorbed radiation became a part of energy is lost due to vibrational or collisional processes. Hence, the emitted radiation has longer wavelength or less energy than the absorbed radiation. Then, in the vibrational deactivation, it takes place through intermolecular collisions at a time scale of 10 to 12 or faster than that of fluorescence processes. So here are the characteristics of time. So absorption, provisional relaxation. So here the lifetime of excited state is 1. So then intersystem crossing, internal conversion, lifetime of excited state. So muna siya. Internal conversion. As electronic energy increases, the energy levels grow more closely spaced. It is more likely that there will be overlap between the high vibrational energy levels of Sn-1 and low vibrational energy levels of Sn. This overlap makes transition between states highly probable. Internal conversion is a transition occurring between states of the same multiplicity, and it takes place at a time scale of 10 to the power of 12 or faster than that of fluorescence process. then the energy gap between S1 and S0 is significantly larger than that between other adjacent states. 2. The S1 lifetime is longer, and to the radiative emission can compete effectively with non-radiative emission. Principle of fluorescence. Stokes shift. The difference between the max wavelength of the excitation light and the max wavelength of the emitted fluorescence light is a constant. Muna siyang gitawag og Stokes shift. So next is the mirror image rule. So as you can see in the picture, the vibrational levels in the excited states and ground states are similar, and absorption spectrum reflects the vibrational levels of the electronically excited state, and an emission spectrum reflects the vibrational levels of the electronic ground state, and fluorescence emission spectrum is mirror image of absorption spectrum. So here are some examples of mirror image. So as you can see in the left picture, so its description is mirror image rule typically applies when only S0 to S1 excitation takes place. And the last picture shows that deviation from the mirror image rule are observed when S0 to S2 or transition to even higher excited states also take place. Types of fluorescence. Based upon the wavelength of emitted radiation when compared to observed radiation. So there are three types of fluorescence. So the first one is the Stokes fluorescence. So the wavelength of emitted radiation is longer than the observed radiation. Conventional fluorescence experiments. Then the second one is the anti-Stokes fluorescence. So the wavelength of emitted radiation is shorter than the observed radiation. So thermally assisted fluorescence. Then the last one is the resonance fluorescence, when the wavelength of emitted radiation is equal to the absorbed radiation. So mercury vapor at 254 nm. So the next one is also the types of fluorescence, but it is based upon the phenomenon. So the first one is the prompt fluorescence, and the second one is delayed fluorescence. So delayed fluorescence are delayed emissions whose spectra coincide exactly with the prompt fluorescence from the lowest single state. The only difference is in their lifetime. Delayed fluorescence. So there are two most important types of delayed fluorescence. So these are the E-type delayed fluorescence and P-type delayed fluorescence. So let's first talk about the E-type delayed fluorescence. So it is the process in which the first excited single state becomes populated by a thermally activated radiationless transition from the first excited triplet state. Since in this case the population of the singlet and triplet states are in thermal equilibrium, the lifetimes of delayed fluorescence and the concomitant phosphorescence are equal. Then the second one is the P-type delayed fluorescence. So it is the process in which the first excited single state is populated by interaction of two molecules in the triplet state or triplet annihilation. So thus producing one molecule in the excited singlet state. In this biopotonic processes, the lifetime of delayed fluorescence is half the value of the concomitant phosphorescence. So next is the exception from Cash's rule. So as shown in the picture, so azulene exhibiting S2 fluorescence in violation of Cash's rule. So this is the picture shown about the azulene exhibiting S2. Then the self-quenching or concentration quenching. So in the left side, so it represents the calibration curve or low con. So mura na siyang differences nila diri sa right side, because in the right side murag nagpa-curve siya, no? Curve which means is this is the high con sa calibration curve sa fluorescing species. So rigidly of structure. So as you can see in the picture, so the fluorescence intensity of 8 hydroxy quinoline is much less than that of the zinc complex. And the last one, I'm going to show you the solvent effect on fluorescence spectra of a spiroxazine. So here, there is the picture. And that would be all for my topic. I hope you understand something from my lesson. Thank you.